So, good morning everyone. The today's training session will be on bank erosion, sediment management and river morphology. Here we will be discussing about what is river morphology, sediment transport and bank erosion. Coming to the introduction, like rivers are dynamic natural system which maintains its flow due to flow variation, sediment supply, and are classified into three. Perennial river, those rivers which flows all the years, months in a year. Imperennial flow only during the rainy season, and in intermittent rivers only for few months in a year. Like we can say Chambal river is the river which flows only for few months in a year. Why it is necessary for studying bank erosion, sediment transport and river morphology? Because we know that rivers are very dynamic in the northeast regions, carrying so much sediments. Because of that, it reduces the discharge carrying capacity of the river, which cause flooding. Frequent change in the river morphology also creates sediment erosion and deposition on the banks of the river, which are taking devastating losses like agriculture loss, infrastructure loss. For these types of study and flood mitigation measures, we are making RBMP in this region. Coming to the river process, as it has been divided into three parts, river morphology is basically a study of river patterns, how river flows, and bank erosion is basically the lateral removal of bank material, and sediment transport is the movement of sediments like bed load, suspended load in the mainstream. These are the few pictures which shows the river morphology pattern in the Brahmaputra river. As we can see, so many places bedding river is taking place, erosion and deposition. And the second one is the Majuli Island, which shows the bank erosion of the river, and the third one is the sediment transport in the Arunachal and Assam basin. Coming to the human influence on river process, as natural rivers are often being accelerated due to human maximum velocity. The probability of getting erosion is maximum on that portion also, and the opposite portion will be deposition of sediments. While continues this process, some portion of the river get extracted out and it forms a lake called oxbow lakes. This caused due to regular erosion and deposition in the river pattern. And understanding this phenomena helps us in flood managing, sediment transport and watershed planning in the river basin. Coming to the types of channel, they are basically divided into four types, like straight, meandering, buried, and an astronomical pattern. Like if a river is flowing in a stable reach, like a channelized river, we call it as a straight type. And if meandering is happening like a sinusoidal channel, we call it meandering. And forming a boulders inside the river structure, we call it as braiding. And if these structures forms an island, we call it as astronomical structures, which forms a like Majuli Island in between the Brahmaputra it forms. Coming to the parameters which has been used for calculating, like if we see the one section of a river in sinusoidal form, from air distance till the last, we call it as meandering length, and meandering width is the distance between the opposite apex of the river, and width is the bank full width. These are used to calculate the sinuosity planform. Like here if we see the planform view of the river and we want to calculate the sinuosity. Sinuosity is basically how much curve a river is forming, and it has been calculated like channel length divided by valley length. And if we want to calculate the wetted parameter and hydraulic radius, we used to calculate it by area divided by wetted parameters, and discharge has been calculated while multiplying area into velocity. If we see the table over here, we define the channel into single channel and multiple channel. If the sinuosity index is less than 1.5, we call it as a straight channel, and if it is greater than 1.5, we call it sinusoidal. This I will be performing in the QGIS to show a river how it is sinuosity is calculated and what is the pattern of the river. Coming to the bank erosion. Bank erosion are basically the removal of bank material due to hydraulic or geotechnical forces. The main mechanism behind it is like tow mechanism, where the river velocity is high and it is eroding the bank of the river. Slumping means weak soil, cantilever failures means under overhanging soils above the river bank, and seepage, the water seep through the bank of the soil, and the causes are both natural and man-made. Natural causes due to flood, meandering pattern of weak soil structures, and human induced like sand mining, development of embankment, deforestation. The impact is loss of agriculture, damage to the structures, and population displacement. These are few of the pictures in the Brahmaputra river where both meandering, braiding pattern, deposition and erosion taking place. As we can see in this structure, here the velocity of erosion is taking much more as compared to here. In all the places like Guwahati also, Dhubri and Dibrugad. The table shows the losses in the northeast which has been occurred due to water bank erosion, and we from this table we found out that Nagaland is the place where most of the erosion is taking place. It is coming around 87%, and total Assam, total northeast region is getting 68% eroded, and when we compared with whole India how much soil is being eroded, it is coming around 39%. Here we have excluded the Mizoram from this table as we didn't got the data. Coming to the sediment transport. Sediment transport is basically a transportation of suspended soil, bed load and wash load from the river bank. Means sediment management can be done by catchment treatment like channelizing the river also, and the way we can measure this like structural grooms. Have you seen the grooms pattern which has been formed perpendicular to the bank of the rivers? Like boulders, these are basically used to keep the sediment inside the river only, not to erode the bank structures. Means if sediment is, erosion is happening one side, automatically the deposition will be happening on the second side of the grooms. Means if sediment is surplus, means aggradation and braiding will be taking place. If it is less, then erosion will be automatically taking place from the banks of the river. Coming to the patterns of the river which is forming, like if we see the figure meandering pattern, as we move from right to left, the meandering is increasing, and we move from here to here, the braiding pattern will be increasing. If we consider the sediment load and braiding pattern, more is the braiding pattern, more will be the bed load, and more is the meandering pattern, more will be the suspended load in the river. And when we compare the sediment grain side, coarser will be founding in the barrette pattern, because these are the structures which forms in the barrette pattern, and here the possibility of deposition takes more places, like boulders used to comes in between, and sediment start depositing on this side only. And coming to the meandering pattern, finer grains particles will be more. Bank stability, here it will be decreasing and here it will be increasing. Discharge variability, higher variability in the barrette pattern and lower in the meandering pattern. And channel slope, here in barrette pattern the slope will be more as compared to meandering pattern. Coming to the methodology adopted for bank line shifting, this methodology has been adopted by various researchers for seeing the how much bank line shift has been taken place in the river. Like here we have collected two data sets, primary data sets and secondary. Secondary mostly like discharge, precipitation, LULC maps developed by different agencies, and in primary data set we use satellite images and topography. Satellite images we take it at an interval of around 5 years or 1 decade, and after getting the satellite image like LULC, we delineate the banks, river banks, and then we overlay different banks, and we'll see whether the river is eroding or deposition taking place on the banks of the river. Based on that we calculate the river morphology parameters also, like sinuosity, and different parameters are also there for calculation. Based on that we identify whether this place is eroded and how much percentage of erosion taking place in terms of area and quantity also, and that has been validated with the field survey also, and to identify which places are critical and non-critical. And here is the methodology adopted to calculate the sediment load and bed change profile. This has been done using the HECRAS software. Basically, a HECRAS model is developed by Hydraulic Engineering Center, USA. It can be used for capabilities like 1D, 2D hydraulic flow simulation, sediment transportation, flood inundation mapping, and also for bank erosion estimation. Here what we call the formula which is used like Sand-Venus equation, which is the combination of both continuity and momentum equation. The methodology adopted is like after collecting the data sets like geometrical data, hydrological data and sediment data, we modeled the HECRAS model, and after that we use different functions like Euler function is there, Mueller function, to see how much sediment analysis is coming in the river pattern. And based on that we calibrate the model and we validate it with the raw data set to see whether our sediment load is coming approximate to the field survey or not. And coming to the case study, this case study is done by the Majusri in 2013. Here they have taken a 3-bank line, 1996, 2002 and 2010, and they found that Manzuli Island is getting decreases in terms of area of around 448.23 kilometers squares in area. If we see three portions, like the pink river is 1996 river line, yellow is 2002 and the blue one is 2010. Here the erosion is taking place because the river is getting shifted towards the island. The same pattern we found it here. That pink line is the earlier one, yellow is 2002 and the blue one is the recent year in 2010. The original line was this and it was shifted here. So the erosion has taken place in this area portion of the river also, and here the deposition has taken place because the river was flowing in this pattern and the river has been shifted to here. So the deposition of sediment taken place in this region, and the overall there was a reduction in area of around 448 kilometers squares while comparing from 1996, 2002 and 2010. Coming to the river width of the Brahmaputra, and it was found by the IIT Guwahati that the average width of the Brahmaputra is increasing from 1973 to 2011. It was around 9.97 kilometers. And this is the bank erosion from Sadia to Dhubri. Sadia to Dhubri, here they have taken 13 river stretch at a distance of around 50 kilometers. And they have taken 5 years interval to see how much deposition and erosion has been taking place on the left bank and the right bank of the river. The up portion is showing erosion, and the downstream portion, which is negative, it is showing deposition on the left bank or at the right bank of the whole river at 13 stretch. One means here it is showing one stretch till 13 till here, means what all erosion and deposition has been taking place along the stretch of the river. And this is the study done by Samra and Acharya in 1916 and 2008 in Kaziranga National Park. They also found that in few places erosion is taking place and deposition. Here the maximum portion is erosion is taking place along the bank of river as compared to deposition. And coming to the case study of Dikrau Basin, here we have taken 2 sentinel images. Based on that we developed the LELC map of 2020 and 2025. We found out that wetland is the area which is increasing around 145%, and the maximum erosion taking place is sandy area is decreasing. It is around -10%. Coming to the tabular form, here we can classify that we have taken 12 classifications of the land, and we are finding out that wetland is the most and forest area is also decreasing. Around it is decreasing around -2.26%, means 2% of area, forest area has been reduced from 2020 2025. This is the LULC map showing the percentage change in different classes. Coming to the key observation from the previous tables, we found out that there was a significant decline in the forest area and sandy area, and urban growth like built up area, industrial expansion, growing human activities in the central and southern plain. Wetlands expansion is also taking place around 145%, indicating improved hydrological condition or restoration in specific areas. Agriculture area is slightly decreasing with a reduce of 203 hectares of area. Other categories grew up by over 30%, indicating a rise in miscellaneous land use land not capturing by primary classes. Here it is showing a sandy area, how it is changing from 2020 to 2025. There was a continuous decline of 10.05 reduction in the area. And here the analysis of land degradation and bank shifting taking place. Here we have taken two images, one forest images of 2020 and 2025. We found out that major forest area is reducing. The red portion shows the built up area which has been man-made industries, and it is showing that forest area is decreasing. And here we have taken a two stretch of the river. The earlier one is around 2020 and the other one is 2025. Here we are seeing that the river bank is shifting. The black line we are seeing here in 2020 and in 2025. The width of the river is changing and it is increasing. Coming to the wetland mapping, analysis near Satnapur and Pakhodola Gaon revealed that there is a dramatic increase in the wetland area from 2020 to 2025. It is gaining a net gain of area around 22.98 hectares. This represents an increase of around 145.5% in just 5 years. Thank you. Now we will be doing a hands-on how to calculate the sinuosity of a river, to identify whether it is a straight river or buried meandering river. Then we'll move to that lab. Stop, na? Yes.